The fifth and last step in our cycle of control is to actively improve standards. So let's dive into that one. Hello, I'm Tom. Welcome to my channel where we talk about operational excellence and how to make it practical for you. And in this series of the cycle of control, the inner circle of the cycles of excellence, we will be talking about all of those points. And in fact, I have already talked about the first four. Today we have the fifth one, which is to actively improve your standards, to make your standards easier, simpler, more stable. And this is something that, of course, you want to do at the end of any problem-solving or improvement effort, but you can also do this as a standalone action. It's good to have a focus on this when you are looking at your systems, your standards that you have within the organization. So what do I mean by this? Well, first off, it is important to know that here we are talking about the input side of the process, right? We have been talking about performance standards. Those are on the outputs of a process. How fast are we? How expensive are we? How much are we making? What's the quality rate? Stuff like that, right? The stuff you usually get in KPIs, key performance indicators, that we also check in our performance control meetings. The inputs, however, they determine the outputs, because the process, that is a physics thing. It'll do the same if the inputs are the same. So there we have basically those 4 M's, right? And that is also going to be our focus area for this type of standards improvement. They both are standards. We do check both of them. But these are the ones that we really want to actively stabilize. Those are the influenceable standards that we have. So what things are we talking about? We are talking about machine settings. We are talking about work instructions. We are talking about material specifications, stuff like that, right? So that's why I said the 4 M's. Now, you have the milieu or environment M, you have the measurement M, basically on their own parts, sort of divide them up into the traditional 4 M's. And also you cannot really manage the standard of environment. So that's why they are not as useful for this exercise. And we just look at the basic 4 M's. For measurement, we do have a set of questions as well, quite specifically. Because what we will be doing with them is be taking them through something I have already explained before in 1 or 2 videos, which is the 5 questions for 0 defects. And that is a system where we look at a standard and we don't really judge how accurate the standard is. We look at how stable it is as a standard. How good is the quality of the standard itself? Now, that's not just the instruction, although it is part of it. That is the whole system around that standard. And we have 5 axes, 5 questions that we judge that standard by. And we get a score that will give us a score of the quality of the standard. And the first 2, they are about the setting of your standard. They are about how clear is the standard to us, to our people, to our organization, and how easy is it to set the standard correctly. If we, for instance, take a machine parameter like the temperature on a sealer roll, then how clear is it? Means, do we really know what that temperature should be? If maybe there is a difference for different products, right? So do we have to set a higher or lower temperature for product A compared to product B? So do we have a clear setting for each of the products? Here, by the way, if every product, with maybe even a couple extra parameters added in, requires their own temperature setting, I would not even rate this a 5. We tend to rate these on a 1 to 5 scale for each of the questions. But the main question here is, do we even know? And do our operators know? Now, if we look at more of a work instruction, so it's like a method standard, then it is how clear is that work instruction? How easy is it to read it? And then the ease to set on the temperature is basically between, if you really have to be twisting some dials and there's no direct feedback, so we measure the temperature on the roller and then have to adjust a little bit more, to sort of medium is, well, you manually set it to good is when you load the product into the PLC, it automatically also sets the parameter list. You can still check it, but it's done automatically. That's sort of the level we're talking about here. And for a work instruction, this is more, how much learning is required and how much understanding is required to actually do what needs to be done. So is this relatively easy to learn, so to set in your person, versus maybe it's super difficult. By the way, every time the super difficult part is on the 1, or the really manual or really specialist, that's the 1, and the automatic or super easy or super stable, we'll see that in a bit, is on a 5. And then you have 3 that are more about how stable and how easy is this standard in process. And so these are more how to set the process correctly. These are how stable is it. So if we set the temperature of this sealing roller, will then it stay at temperature? Now this can be because there's just a very good thermometer feedback loop, right? So it does not mean that the machine does not need to do anything to keep the temperature. It needs to continue to heat. But if there is an easy feedback loop, that's good. Bad here is that really within a shift, within working runs, you really need to be adjusting the temperature on a pretty frequent basis. A 5 here is set and forget, basically, right? There is a good feedback loop. If you set the temperature to 180 degrees centigrade, it'll stay there. So if it is then, especially if it's not so stable, but maybe something just happens, if it does go out, how easy is it to spot that it went out of setting? Because there is a difference here, right? Maybe it goes out of setting a lot or almost never. That's how much it happens. But if it happens, how well can we spot it? With a 1 sort of being, you need to actively look for it. A 3 being, it's sort of automatically spotted at the end of the process. Maybe here, probably 1 or 2 processes down the line, but it's a clear connection. If it's further down the line, or it's a relatively quick connection when it's done immediately in your process, to level 5, it's always detected at this same process. Maybe it's already even, that's a true level 5, detected as soon as the temperature goes off. It's just not automatically corrected, probably, but there is an immediate detection or a very good automatic detection at the end of this process. So this is how quickly do we know. But then, how easy is it to correct that process? A little bit the product, but mainly the process itself. So those 2, they are linked, right? How easy is it to set the temperature, especially in the beginning, but also how easy then is it to correct it if it does go wrong. But they are not the same. Now, with a temperature setting, it's sort of the same and linked, although if we have a sealing roller and we're sealing plastics, then quite often a bit of the plastic gets onto the roller or onto the iron. So you can set the temperature higher, but the actual temperature getting on your new plastic, your to-be sealed plastic, is different. So it was easy to initially set the temperature, but then due to something else than purely setting the temperature, in this case, dirt buildup, contamination buildup on your equipment, you need to scrape that off somehow during production. That is not easy. See the difference? And temperature is a relatively easy, relatively the same thing if we're talking about the correct position of your blocks that fold a box or whatever, right? During initial setup or later are very different. During initial setup, it can be easy or not, depending mainly on, do we know how to set it up? Do we really know these parameters? And do we have blocks in place that we can just fold it around? Or does our machine even have a way to save settings? While during production, it's much more on, can we do small adjustments while the machine is running? Probably, right? So This is a different type of correction of the settings. That's why both of them are in here. Now, all of these, they get a ranking of 1 to 5. And you can do this if you go to my, for instance, my problem solving template. You will see that because you do this well at the end of problem solving, at the end of an improvement team, you create new standards. That is the moment to definitely do this as well. You see the questions worked out in that template. So go and download the template if you have not done that before. But there is a different set of trigger questions for machine, materials, man, method, and even for measurement devices. And it generates a scoring between either 5 and 25, or we multiply it and make sure it's between 20 and 100 percentages. Right? And that gives you a scoring, and with that, if you do it for multiple standards, a ranking of the quality of your standard. So then you just make a nice list. And all of them, they get a score on each of these. Right? So it can be pretty easy, but difficult to set, very stable, pretty good to detect, but then again also difficult to reset. If it did go wrong, we add all of them up together and we either get, in this case then 16 or multiply it by 4. But like this we get scores, and each of these gets their own scores, right? Ideal one, pretty poor one, somewhere in between one. And when we score it like this, you can also, purely based on the quality of your standard, go and improve it. And so we know, and this is something we actually do a lot in TPM style programs, but basically in any continuous improvement program, we want to stabilize and improve the input standards. So we can go and look for better settings, which is very Six Sigma, but we should also make sure that the standards are just more stable or better. And this is the way, because if we see a very poor score here, that is a prime candidate to be looking into, not per se in we need a better info on what the setting should be, but on how can we make it as easy as possible for the operators, for the mechanics, for the lab technicians, for our whole organization to set and maintain this standard. That will seriously boost the stability of ingoing parameters, and by that the process itself, and by that stabilize your outcomes, right? Your performance. So that's why you do this. Now, of course, you have a whole bunch of these input standards, right? Every process has a whole bunch of them. If you're going to all list them and really go through these questions, that is a lot of work. Now, some companies really do this and get good results from it. I would advise you to do it sort of step by step, right? So what you can do is definitely any problem-solving improvement team, you ask them to do this, do the standards that are critical to whatever process or whatever problem they are working on. That way, you get nice, high impact and relatively low resource cost, because that team already has to look into those standards. But also, you want to be mapping your processes and their inputs anyway. This is a good thing to do. This is the farming mindset more than the hunting mindset. Check out the farmer and hunter videos as well that I have. But then pick the most important processes. So in food, for instance, quite a common priority is your critical control points, your CCPs. Let's check first the quality of inputs on your CCP measurements, your CCP settings, and make sure at least they are good. And here, and that's important, one CCP, like a metal detector, is quite a common critical control point for food. It has an instruction, it has a machine, it has a measurement characteristic. So you already have a number of these M's for that one process of a metal detector on a filling line. So just picking CCPs already gives you quite a list. That's why you go through this process relatively slowly. The good thing about this is, of course, if you see that the way you write your instructions is a bit difficult, right? It's just written maybe for an auditor, but not really for the operator that has to use it afterwards. This is a systemic thing. This is almost certainly going to happen throughout your organization. So when you start improving that, you will see scores go up for all of your standards. You do not need to do this active improvement of standards for every last standard in your factory. Start with the important ones and make sure that any team that is touching standards anyway also does it, and then you get a very nice balance. With that, you close out the cycle of control, because in this manner you know what your process is, right? That's the black arrow always here where all of the cycles touch. We have standards, that's how we get here. These are our work standards, inputs and outcomes. We make sure we have training material, people are trained. We make sure people follow all of the standards, very much focused on these inputs to process, right? Process control. We have performance control, where we check the outputs. If any of these has deviations, we make sure that we solve those problems. We restore our processes to the standard. And then we improve, actively improve our standards themselves. If you do that cycle of control in a good way, you will see so much benefit to your organization. In fact, if you are thinking about, oh, what part of TPM, what part of operational excellence can I start with? It's just too much to do everything. The cycle of control always pays off, right? So you would like to have a program that touches all three cycles, but the cycle of control, that is so foundational. If you do not do that, the rest is sort of wasted effort anyway. And that's why go through those videos, make sure you do that in your organization. In the end of that, come back to actively improving your standards and stabilize and improve your processes. If you would like to know how to do these things for your organization, I'm happy to help. Just get in contact with me. For now, I wish you the best in applying this to your processes. Let me know down in the comments how that went. And as always, don't forget to enjoy the continuous improvement journey.